A major challenge before the scientists at the end of 19th century was to reveal the structure of the atom as well as to explain its important properties. Here we shall learn about the subatomic particles and the various models that have been proposed to explain how these particles are arranged within the atom. Atoms have three types of subatomic particles. They are the electrons, protons and the neutrons. Electrons are negatively charged, protons are positively charged and neutrons have no charge. The mass of an electron is 1 by 2000 the mass of a hydrogen atom. The mass of a proton and that of a neutron is equal to the mass of a hydrogen atom and is taken as 1 unit. Now, do you know by who, how and where and when these subatomic particles were discovered? In 1900, J.J. Thomson discovered the presence of the negatively charged particles called the electrons in the atom. In 1886, E. Goldstein discovered new radiations in gas discharge and called them the canal rays. These rays were positively charged. This later led to the discovery of positively charged particles called the protons in the atom. In 1932, Chadwick discovered the presence of particles having no charge in the atom and called them as neutrons. Now coming to the structure of an atom. For explaining this, many scientists proposed various atomic models. J.J. Thomson was the first one to propose a model for the structure of an atom and called it as the Thomson's model of an atom. According to Thomson's model, an atom is similar to a Christmas pudding. The pudding had positive charge and the electrons having negative charge were like plums on the pudding. So basically, Thomson proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and the positive charges are equal in magnitude. So the atom as a whole is electrically neutral. Although Thomson's model explained that atoms are electrically neutral, the results of the experiments carried out by other scientists could not be explained by this model. Ernest Rutherford was interested in knowing how the electrons are arranged within the atom and he designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted as thin a layer as possible. The gold foil was about 1000 atoms thick. Alpha particles are doubly charged helium ions. Since they have a mass of 4u, the fast-moving alpha particles have a considerable amount of energy. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. But the alpha particle scattering experiment gave totally unexpected results and these were his observations. Most of the fast-moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. From these observations, Rutherford concluded from the alpha particle scattering experiment that most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. A very small fraction of alpha particles deflected by 180 degrees, indicating that all the positive charge and the mass of the gold atom were concentrated in a very small volume within the atom. From the data, he also calculated the radius of the nucleus, which is about 10 raised to 5 times less than the radius of the atom. So, on the basis of his experiment, Rutherford put forward the nuclear model of an atom, which had the following features. Firstly, there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. Secondly, the electrons revolve around the nucleus in circular paths and the size of the nucleus is very small as compared to the size of the atom. But there were drawbacks in Rutherford's model too. We know that any particle in a circular orbit would undergo acceleration. And during acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atom should be highly unstable and hence matter would not exist in the form that we know. But we know that atoms are quite stable and Rutherford's model could not explain this. So this was the drawback of his model. In order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward some postulates about the model of an atom. He proposed that only certain special orbits known as discrete orbits of electrons are allowed inside the atom. So while revolving in discrete orbits, the electrons do not radiate energy and these orbitals or shells are called as the energy levels. These orbits or shells are represented by the letters K, L, M, N, etc. or the numbers n equals 1, 2, 3, 4, etc. So that was about the Niels Bohr model of atom, and this is a widely accepted model even today. So to summarize, atoms have three types of subatomic particles. They are the electrons, protons and the neutrons, and the different models that were proposed to explain the structure of an atom were the Thomson's model, the Rutherford's model, and then came the Bohr's model of an atom.